Okay, hello guys. Today we are talking about the transformations of functions, okay? So let's move into the first slide of it. So let's making a quick overview about what is basic transformations of functions. So we can say here, the first kind is called translation. And we have the vertical changes and the horizontal changes, okay? Like if you're moving a graph upward or downward, we can say it's a vertical change. And if I'm moving like from left or to right, we can say it's a horizontal change, okay? So here are two kinds of the translations. First is y equals to fx plus a. That means here we move upward for a unit, okay? So you can also write down the vector as 0a, okay? So that means there's no change in x-axis, but here there will be a change in y-axis, and here is plus a, right? Okay. And another is called horizontal translation, and here you can written down as y equals to fx plus a. But remember here, this translation means move the graph left by a unit, and it can also be written as negative a0, okay? So you can just try to use a very basic principle to explain this, like moving to the left, we can say it's minus, moving to the right is a plus, moving up, oh sorry, moving left is a plus, right? Here's a plus, right? So left is plus, and the right is for minus, and moving upward is plus, and moving downward is for negative. So maybe it's a quite different symbol as we know in the coordinate, right? But here, that is just how to written down the function right here. But for vector, moving left is a negative. That is for sure because the unit or the coordinate have a little bit smaller, okay? That is how we can understand this. And the second transformation is called stretches. So we have the first is vertical stretch. Like here, we said a basic function times a, that is a times fx. So we can say that here it means multiply y coordinate by a unit. Okay, so we can also say here that stretch is a factor a parallel to y-axis. Okay, the second is called horizontal strategy. So you can say here when we're just using a times into x, that means divided x coordinate by a, or you can say the sketch factor is for 1 over a. Okay, so you can find for the x-axis, it's very quite different to compare with the y-axis, right? The y-axis always like we plus means moving upward and we using negative means moving downward, right? Okay, so all of this is like this way to understand it for this, okay? That is it. Okay, and let's just trying to have the third one is called the reflection, okay? So reflection means that here we can just trying to understanding it as y equals to negative fx means here we has y becomes the negative y, okay? That is it. And when we are just using it to have a y reflection, like here, maybe here this point to B point to A point, that means you can find y value doesn't change, but for x value, it turns a negative value, okay? So we can say here that the graph flips horizontally from B point to A point, okay? That is it. Okay, so maybe here we can say, oh, maybe right here for B to A, okay, so here that is a flip horizontally, okay? So for example, like here, is that considering about y equals to 2fx plus 3, okay? So it's that right here, order of operations, and you can just trying to find what is the translation from fx to this 2fx plus 3, okay? So let's try to understand it together to how to find the transformation among this. So first of all, we can set fx, we can first turn into the 2 times fx, and then you can say 2fx plus 3, right? Okay, that is it. And we can set it right here. For fx turns into 2fx, that means the y value doubles, right? Okay. So here, y value doubles also means that maybe for here, that for the y value times 2, right? Okay, that is it. And also we can set here, after it, it means stretches for 2 times on y-axis, and also added 3 means that it has a translation upward for 3 units, right? Okay, that is it. So here means that stretches on y-axis for 2 times. And 2fx plus 3 means here we moving upward for 3 unit, right? Okay, that is it. And the second example is to describing the fun transformations, okay? Like here, oh, maybe we can set right here for y equals to x squared turns into y equals to 2 times x minus 3 squared plus 1. So first, we can set x squared turns into x minus 3 squared, right? And then turns into 2 times x minus 3 squared, and then turns into 2 times x minus 3 squared plus 1, right? So for the first transformation, x squared to x minus 3 squared, we can say here that first it has to make x, it turns into x minus 3, right? So we said from the right, it means the negative, and from the left, it means the plus, right? So here, it means moving right for 3 units, right? Moving right for 3 units. And the second here is, we can set that from x minus 3 squared turns into 2 times x minus 3 squared. So we can set here, that means it stretches on y direction for 2 times, right? And the final list change because 2 times x minus 3 squared plus 1, that means we are moving upward for 1 unit, right? Okay, that is it. So we can set here, that means here it is moving upward. Okay, so you can just say the translation at the first time is the x maybe moving right 3 units, right? And it is for 3, 0, okay? 3, 0. And maybe after that, maybe we here multiply by 2, it means that the vector stretches factor by 2. And the third is moving upward, that is 0, 1, right? The 3 vector can represent for the transformation among this, okay? And here is for final student exercise for you to try to understanding how it is. So first, from y equals to fx to y equals to negative fx plus 2, we can stop right here. It means, oh, maybe first fx turns into negative fx, and then it's from negative fx plus 2. Okay, so for fx turns into negative fx, it means that here we first flipped. We just have a reflection among x-axis, right? Okay, that means x-axis. And from negative fx to negative fx plus 2, it means moving upward for 2 units, right? So here is for 0, 2, okay? And here, maybe for another is for y equals to fx2, y equals to f2x minus 6, okay? So because here, maybe the x turns into, first fx turns into fx minus 6, and then turns into f2x minus 6, right? So for fx turns into fx minus 6, it means that moving maybe right for 6 units, right? Because we said right is negative and left is positive, right? So right for 6 units, that is 6, 0, okay? And then x turns into 2x, that means we have to like times for a half on the x-axis, right? So it has been shrinked in the original, maybe we can say original, maybe shape for it, right? Okay, that is it. So because that is for the 2 changes of the transformation, okay? Hope you understanding for all of the transformation today we are learning. So see you next time. Bye.